Hello everyone, in this video we're going to be looking at the solution to the LeetCode problem, longest substring without repeating characters. So the title itself gives away what is there in the problem, and that is that we have to find the length of the longest substring without repeating characters in a given string. So without repeating characters meaning that all the characters in that substring has frequency of 1. No character is being repeated. So let's take an example. We have A, B, C, D, D, P, Q, R. So you can see that the longest can be 4 with either A, B, C, D or D, P, Q, R. So we have to find the longest substring with unique characters. So how will we do that? We'll be using sliding windows technique, which is just a fancy way of saying that we'll be checking all these substrings. But we'll be doing that within one loop in O of strings length time. So how will we do that? So what we'll be doing is, let's just take an example, a better example. So A, B, C, C, D, E, F, F, Q, R, P. So what we'll be doing is we'll have two pointers, L and R, and L to R will be the substring we're checking. So L will be 0 initially, and R will grow from 0 to the length of the string. So L is 0, A. R is also 0. So R will go on till we find a node which starts repeating. So we'll have a map which will mark the characters as true or not. So if we're finding the characters for the first time, we'll mark them as true. And if they're already true, meaning that we found them for the second time, meaning they're being repeated. So when they're being repeated, we'll update L. So for example, I come L to R is this, then this, yeah. So L to R is first this, then this, then this, then it starts repeating. So what I do is I update L, first I store the size which is 3, then I update L and then it starts moving from here. So C, D, E, F, F, again it starts repeating. So I take a step back, store the size and then update L. So then an R is traversing, then L is this. Then we start from here, then here, 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 and towards the end again we'll store the size, and from the size we'll find out the maximum size. So it's a very simple approach. So first let's take care of the corner cases. If s dot length is equal to 0 or s dot length is equal to 1, then simply return s dot length. Because if it is 0, meaning that there is no string, then the longest substring will obviously have the size 0, and if there is only one character, then the longest substring will be 1. So we'll have a variable called max, and the lower bound for max will be 1. Now why is it 1? Because the lowest value of the substring that we can have for a string will be 1. So even if we have a, still the longest or the maximum size will be 1, because every individual character in the string is a substring without repeating characters. So like I said, we'll have two pointers, L which will be 0 and R which will use. And we'll have a Boolean map which we'll be using to store. So initially the map of all the characters will be false. If it's not been visited, then its map will be false. If it's visited, then I'll map it to true. And if it is already true, meaning that it is being repeated. So you'll see how it works. Now is equal to new Boolean array of length 255. Now why 255? Because it's ASCII, so all of the characters will be from the range integer range 0 to 255. So for int I is not int, yeah, int r is equal to 0, r less than s dot length, r plus plus. So r will be using to traverse, and let me just write down that L to R is substring we are checking. So L to R is a substring that we are checking. So R is 0, R goes from 0 to s dot length, and two things will happen. Either we're finding the character for the first time, in which case its map will be false. So s dot char at R is false. So this is the case where we're finding it for the first time, so its map will be false. So if its map is false, then nothing to do, we'll simply make it as true. So map, I'll just copy it. Map of s dot char at r is true, so meaning that we've visited it once. So if we again come across this, then it starts being repeated. And then the else part. Suppose I find it for the second time. So if I have say I have A, B, B. So I come across A, it's for the first time, mark its map as true. I come across B for the first time, mark its map as true. Then again I come across B, but its map is already true. So in the else part will come. And what we'll do in the else part is while s dot char at will update L. So while s dot char at L is not equal to s dot char at R, then first we'll make its map as false. Now why are we making its map as false? Because suppose I have A, B, B, C, D. So at coming to A, B, I mark its map as true. Then again here I mark its map as true. Now when I update L, meaning I'll start B from here, then I'll be taking B again in the next substring. So its map has to be false then. So in BCD, I can again mark maps as B's map as true, C's map as true, D's map as true, and then find the substring length. So map of that is false. S dot char at L is false, and L plus plus, so we can eventually reach the next L, meaning that the next lower bound of the substring, and then L plus plus. So now L is the next lower bound of our substring, and R will keep on going. Then simply we just find the length, and if it is greater than max, then we update max. So math.max, max itself, and R minus L plus 1, which is the size of the substring. Then what we do is we return max. Okay, so what we're doing again is we're having L fixed initially, then we're traversing R. As soon as we find the character repeating, we update L and R, and we move on to check the next substring. So let's try to run it. Okay, seems okay. Okay, and you can see that the runtime is 5 ms, which is not bad because a few ms don't really have that much of a problem. So again, we use a simple approach of traversing throughout the string and checking all the substrings. And as soon as a substring was from L to R, and as soon as we found a character repeating in the substring, we updated our substrings L and R to from the next character. So that's all. Thank you.